Hello, I'm Tim Beggins, president of Elk Trading Company. In today's article, winter storms Uri and Elliott, atmospheric drivers and energy system impacts. In today's article, we've got the estimated snowfall for winter storm Uri back in 2021. This snowfall covered everything in the west, all the way down to Dallas and Houston in Texas, and all the way back up to Chicago and New England. As you can see, this was a major storm. And what's important about both Uri and Elliott, they formed during La Nina weather conditions. Winter storms Uri in February 2021 and Elliott these 2022 were extreme cold events with distinct atmospheric mechanisms but similar outcomes, systemic stress on U.S. energy and infrastructure. Uri was a polar vortex disruption and persistent blocking. Uri's severity was tied to a major stratospheric sudden warming, or SSW, that destabilized the polar vortex, producing a record-tying negative Arctic Oscillation, or AO. This amplified jet stream undulations and established a blocking ridge over the western U.S., funneling Arctic air deep into Texas and the south. Subfreezing temperatures persisted for days. Austin bottomed near 6 degrees Fahrenheit, compounded by snow and ice. A surface low, approximately 992 millibars, reinforced the cold outbreak. The persistence of cold stressed ERCOT's grid as generation, gas, coal, wind, and nuclear faltered under freeze-offs while demand surged. And Winter Storm Elliott, which was a rapid cyclogenesis and broad geographic reach. Elliott evolved via bombogenesis, I'm going to trip over these words, with central pressures dropping approximately over 24 millibars in less than 24 hours. This bomb cyclone was less about AO phase and more about a baroclinic clash of Arctic and subtropical air masses. Its hallmark was rapid onset, 30 to 50 degree Fahrenheit temperature clashes in hours, coupled with expansive wind gusts over 70 miles an hour and blizzard conditions. Impacts stretch coast to coast, from blizzards in the Midwest to freezes in Florida. Texas again faced extended sub-freezing temperatures with natural gas supply constraints, echoing vulnerabilities exposed during Uri. The contrast and implications. Uri, an SSW-driven, quasi-stationary, long-duration cold. Elliott, baroclinic-driven, explosive, deepening, wide area, high winds. Both events demonstrate how different synoptic scale mechanisms can yield similar stress outcomes: fuel supply disruptions, grid instability, and cascading failures in critical systems. With climate variability influencing jet stream behavior and storm intensity, resilience planning must integrate grid weatherization, renewable demand side flexibility, and cross-sector risk management. You can learn more on the article links included in today's article from NOAA, the NCEP reanalysis, and historical storm data. Let us know your thoughts in the comment section below. Please hit that like and subscribe button. Thanks for listening. We'll see you soon.